y dx if x equals tangent of x minus 3 secant of y. Okay, we will be using implicit differentiation because we have both x's and y's. The derivative of x will be 1, and then equals the derivative of tangent x is secant squared x minus the derivative of secant y is going to be secant y tangent y, so the 3 is going to tag along, 3 secant y tangent y, but since we're taking the derivative with respect to x, we're going to have dy dx. All right, now we just need to get dy dx by itself, so I'm going to move the secant squared x by subtracting it, so I'll have 1 minus secant squared x equals negative 3 secant y tangent y dy dx, and then my last step is we'll just divide by the negative 3 secant y tangent y. So then dy dx will equal 1 minus secant squared x over negative 3 secant y tangent y. Okay, number 18, if x squared plus 3xy plus y cubed equals 11, then what is the value of dy dx at negative 5, 1? So we want to find the derivative, and then we'll plug negative 5, 1 into it. All right, I do know that we're going to use implicit differentiation. I also notice on this middle part it's going to be a product rule, so this part will be my f, and this part will be my g. Okay, so my f prime, the derivative of 3x is 3, and g prime, the derivative of y will be 1 dy dx. All right, so I'm ready to take the derivative. The derivative of x squared is 2x, and then plus, we're going to use the product rule, f prime times g will be 3y, and then plus f times g prime will be 3x dy dx, and then plus the derivative of y to the third will be 3y squared dy dx, and then that will equal the derivative of 11, since it's a constant, will be 0. Okay, everything but the dy dx I'm going to leave on the left side. Everything else I will subtract to get rid of. So we will have 3x dy dx plus 3y squared dy dx will equal negative 2x minus 3y. The next thing that I will do is factor out a dy dx. So even though I could factor out a 3, I'm only going to factor out the dy dx. So I'll have 3x plus 3y squared. That will equal negative 2x minus 3y, and then we will divide to get the dy dx by itself, so dy dx will equal negative 2x minus 3y all over 3x plus 3y squared. Okay, and then from here we just need to plug in the values that they gave us. The x is the negative 5 and the y is the 1. So let's see, negative 2 times negative 5 minus 3 times 1 over 3 times negative 5 plus 3 times 1 squared. Okay, that will become 10 minus 3, and then the denominator will have negative 15 plus 3, so we will end up getting negative 7/12 as our answer. Okay, 19, consider the curve x squared plus y squared minus 3y equals 9. Part A, at what value, or at values, does the curve have a horizontal tangent line? Well, horizontal tangent lines would occur when the derivative is equal to 0. So the first thing that I'm going to do is find the derivative, and I'm going to come down here to do this. We are going to get to use implicit differentiation again. The derivative of x squared will be 2x plus the derivative of y squared will be 2y dy dx minus the derivative of 3y will be 3 dy dx, and then equals the derivative of 9, since it's a constant, will be 0. Okay, I'm going to subtract 2x from both sides so that just my dy dx's are on the left. So I'll have 2y dy dx minus 3 dy dx is equal to negative 2x. And now from here we'll factor out a dy dx. So dy dx times the quantity 2y minus 3 is equal to negative 2x. Now we'll divide to get dy dx by itself. So dy dx will equal negative 2x over 2y minus 3. Okay, remember we wanted to find out for this part A, when will the derivative equal 0? Well, the derivative will equal 0 when the numerator is equal to 0. So I'm just going to take the numerator and set it equal to 0. And if I divide both sides by negative 2, that will happen when x equals 0. And you do not need to find the actual point, it just says a value. So when x equals 0, we will have a horizontal tangent line. Okay, then part B, it says at what value does the curve have a vertical tangent line? Well, we know vertical tangent lines would be where the derivative is undefined. So if I'm looking for this derivative, where's that undefined? That would be where the denominator equals 0. So we'll set the denominator equal to 0, and when we do that, I'll get 2y equals 3 So I'll get y equals 3 halves. So that's where I would have a vertical tangent line.